Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2024, Paper 2, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Today's lesson, we will start from question number 5. We will talk about electricity. We will also talk about waves. And the last question, question number 7, is about radioactivity. So we are gonna talk about electricity, waves, and radioactivity. Let's study together. Let's improve together. Question 5, part A says, state Kirchhoff's second law. Kirchhoff's second law simply tells us that sum of EMFs in a closed circuit is equal to sum of PDs. So simply we can say sum of PDs. So this is Kirchhoff's second law. Now let me explain you this one with one very simple example. Imagine that we have one single battery and we have two resistors. Let's say they are connected in series. So these are two resistors. They are connected in series. Let's say the EMF, the PD, the EMF of this one. So we can say, let's say the EMF of this one is equal to V. In this case, we are assuming this battery has no internal resistance. So the terminal PD across the terminals of this battery is the same as EMF of this battery. So V is EMF. And let's say the PD across this resistor is V1. So this is V1. And PD across the second resistor, let's say this one is V2. We can also say this is EMF. So EMF is equal to V. So it simply means that EMF is equal to V1 plus V2. If we have more batteries, they are connected in series, then you will sum up all the EMFs. So main thing is you need to understand, in any closed circuit or in any closed loop, sum of EMFs is equal to sum of PDs. We can also understand this one in a little bit different way, Kirchhoff's second law. We can say in any loop means if we are saying closed loop, delta V should be equal to 0. It simply means that if we start from one point and you go in one direction and then come back to the same point, so this is one closed loop. So delta V should be equal to 0 because delta V at this one point is equal to 0 because potential has only one value. So the difference is equal to 0. So simply we can say delta V is equal to 0. And this law is based on conservation of energy. So it's also important to understand this law is based on conservation of energy. You can understand from here chemical energy is converted into electrical. So we can say in battery, chemical energy is converted into electrical, and then in the resistors, electrical energy means in the resistors, electrical energy is converted into thermal energy. So we can say electrical into thermal energy, or light we can also say, plus light if temperature is too high. If potential is too high, temperature will be too high. So thermal plus light, or you can simply say thermal energy. That is quite enough. So we can say thermal energy. So this is simply thermal energy. So it means this chemical energy has been converted into thermal energy. So chemical energy is equal to thermal energy. So energy is conserved, and this law is based on conservation of energy. Now let me show you the answer, how you can write down the answer. So this is how you can write down the answer. If you write down in this form, you will get 1 mark. And this is the B mark, it should be in your answer. Part B says a battery of electromotive force 9.0 volts and negligible internal resistance is connected in series with a variable resistor X and a thermistor Y as shown in figure 5.1. Figure 5.2 shows the relationship between temperature and resistance for the thermistor. So we have resistance on y-axis and temperature is on x-axis. Part B1 says the current in the circuit is 1.1 times 10 to minus 2 amps. The potential difference across Y is 4.0 volts. Calculate the resistance of X. So current in the circuit is given to us and we need to find out resistance of X. In order to calculate resistance of X, we need the PD across X. So we can say this is Vx. So what is value of Vx? PD across Y is given to us. We can say this is Vy. So we have PD across Y. PD across Y is equal to 4.0 volts. So this reading is 4 volts. And terminal PD across the terminals of the battery is 9. So it means this is 5.0 volts. 5.0 volts. So it's better you also write down this one 4.0 volts. So this is 4.0 volts. Now we have value of Vx. Vx is equal to 5.0 volts and we have current in the circuit Ix, that is equal to 1.1, and this is the total current in the circuit as well. So current passing through X and Y is the same. So we can also say this is I total times 10 to minus 2 amps. Now we need to find out value of resistance Rx. So Rx, simply you have to use Ohm's law, V is equal to I times R. So in this case R will be equal to V divided by I, and V is the potential difference across that component and I is current passing through that component, and component in this case is X. So we can say this is Rx, this is PD across X, this is current passing through X. Now simply we can plug in values. We have 5.0, this is 5.0 volts. We can write on this is 5.0 volts and current is 1.1 times 10 to minus 2 amperes. If we solve this one up to 2SF, we will get 450 ohms because this one is resistance. So this is resistance. So simply you need to write down 450 because given data has 2SF. So final answer also should have 2SF. So this is the final answer. The second part says the temperature of Y is changed to 190 degrees Celsius. The resistance of X remains unchanged. Determine the new potential difference across Y. Means we need to find out what is value of potential difference across Y now when the temperature of thermistor is 190 degrees Celsius. So if you look at this given graph at 190, so at this point we have 190 degrees Celsius. So this is 190 degrees Celsius. We can read the resistance of thermistor, and this is equal to 25 ohms. So resistance of thermistor is 25 ohms. We can say resistance of Y, this is equal to 25 ohms, and resistance of Rx we have already found, that was equal to 450 ohms. We need to find out value of V. So V in this case simply will be equal to the resistance of Y divided by resistance of Y plus resistance of X, and this will be multiplied with EMF, that is equal to 9.0 volts. So simply we can say EMF. So now we can simply plug in values. So we can say V, this will be equal to 25 divided by 25 plus 450 multiplied by the terminal PD across this power supply, that is equal to 9.0 volts. Now if we solve this one, we will get 0.47 volts. So this is value of PD across Y. It has to be up to 2SF because given data has 2SF. So this is our final answer. Third question says the resistance of X is increased. The temperature of Y remains at 190 degrees Celsius. By reference to current in the circuit, state and explain the effect of this change, if any, on the potential difference across y. So few points you need to understand before you start answering the question. It is given to us current in the circuit by reference to current in the circuit. You can use this one as a hint, or you have to use in your answer what is effect on the current when resistance of X is increased. It must be in your answer. So how we can answer this? First thing we need to understand what is happening to R total resistance. This is equal to Rx plus Ry. Ry is constant in this case because temperature remains constant, and resistance of Y at 190 degrees Celsius is equal to 25 ohms. We have discussed in the last part. Now if Rx increases, it means that R total increases. If R total increases, what is effect on I total? So we can say I total. This will be equal to 9.0 volts divided by Rx plus Ry. Ry is constant, Rx increases, so it means that I total decreases. Now if I total decreases, what is effect on Vy? Vy is equal to I times resistance of Y, and in this case Ry is constant, so if current decrease, it means that Vy will decrease. If Vy decrease, what is effect on Vx? So we can see from here. So if Vy go down, and this is constant, so it means Vx should increase. So these are the points you need to understand. This is how we answer questions about circuits. This approach you have to use, and these things should be very clear to you. Then you can handle questions on circuit. Now how we can write down the answer? To write down the answer, we can mention these points. We can say in this case resistance of X increases, as we have discussed here. Resistance of X increases, so total resistance increases. We have discussed here total resistance increases, and total current in the circuit decreases, as we have discussed at this point. As current of Y decreases, we have discussed as current of Y decreases, so PD across thermistor Y decreases, then PD across X increases. So these are the points. So this is how you need to answer. So when you answer questions on circuit, you have to use a systematic approach. Question 6 is light of a single frequency is incident normally on a diffraction grating. An interference pattern of bright and dark fringes forms on the semicircular screen shown in figure 6.1. The light has wavelength of 520 nanometers. The separation of the lines in the grating is 3.8 times 10 to minus 6 meters. Determine the total number of bright fringes formed on the screen. So in this case we have lambda, and value of D is also given to us. And this is a typical question about diffraction grating. So simply we have to use d sine of theta is equal to n times lambda. Question is asking us total number of bright fringes. It means that n maximum. So we can say d sine of theta. This is equal to n max, means maximum number of bright fringes, times lambda. And maximum number of bright fringes is formed when sine of theta is equal to 1, means n max. For n max, we can say for n max, theta should be equal to 90 degrees. This is maximum value of theta, means at this point bright fringe can be formed. So the angle from the center bright maximum from here, this angle can be 90. So you can simply imagine from here. So if we rotate this one, this maximum angle where we can see the bright fringe from the center maximum, this angle can be 90 degrees. So we can say for n max, theta has to be 90 degrees. So sine of theta is 1. So we can also write down here sine of theta means sine of 90 degrees. This is equal to 1. So simply we have d, this is equal to n max times lambda. So n max, from here we can say that this is equal to d divided by lambda. Value of d we have, that is equal to 3.8 times 10 to negative 6 divided by 520 nanometers, means 10 to minus 9. Now if we solve this one, we will get 7.4 3. So this is the maximum number of bright fringes, means we can have 7 bright fringes here. So this is 1, and here can be 2, here can be 3, here can be 4, here can be 5, here can be 6, here can be 7. There is no half fringe or less than 1 fringe. It can be 1 complete fringe or no fringe. So it means we have 7 here. So 1 we will have here 8, and 7 we will have here. So 7 bright fringes here. So we can say 1, 2, 3, 4, 5, 6, 7, like this. So what is the total number? N total now we need to find out. So N total, this is equal to 2 times of N max plus 1 center maxima. So in this case we have 7 times 2 plus 1. So total number of bright fringes are 15. So we can write on here 15. So complete fringes you have to take. So even if you got answer, you got 7.3, even you got answer 7.8, so you have to take complete number of bright fringes, means 7 bright fringes, not 8. So always lower number you have to take. So this is also equal to 7. This is also 7, means 7 complete fringes, bright fringes. So total number of bright fringes we have 15. A typical question you will see in many past papers. So this is when you need to calculate total number of bright fringes. So you can find out maximum value of N, then you can use this formula and you can find out number of bright fringes. And for maximum number, total number of bright fringes, this condition you need to understand theta should be 90 degrees. So sine of theta should be equal to 1. Part B says the light is replaced with a red light of a single frequency. State whether the frequency of the red light is greater than, less than, or the same as the frequency of the original light. Lambda of original light was given to us, that was equal to 520 nanometers in the last part, and the lambda of red light is about equal to 700 nanometers. So as in this case, lambda for the red light, this is greater than lambda for original light. It means frequency of red should be lower. Frequency of red should be lower than frequency of original light. So simply we can say frequency of original light is greater, or we can say frequency of red light in this case. Better way to say is frequency of red light is lower than frequency of original light. So this is our answer, and this is how you can write down the answer. Only one point you have to mention. Now for the second part, we need to state and explain effect of this change on the number of bright fringes formed on the screen. A calculation is not required. Number of bright fringes, is question is asking us state and explain the effect of this change on the number of bright fringes formed on the screen. We have already discussed that N max is equal to d divided by lambda. You can also understand, if write on this one again, you can say d sine of theta. You can understand a little bit in detail. This is equal to n times lambda. As theta is 90, so it means d max, this is equal to n times lambda. So from here we can say n max, so this is over n max, so n max is equal to d over lambda. In this case, lambda has been increased, but d is constant. We are using the same diffraction grating, so it means that n should decrease. So this is our answer. So first thing we need to say, total number of bright fringes, this will decrease. Then we need to explain, because d is same as lambda has increased, so n will decrease. So fewer bright fringes will form on the screen. So this is how you need to answer. This question has 2 marks. 1 mark for stating what is happening to n, and the second mark for explaining. Now let me show you the answer, how you can write down the answer. So this is how you can write down the answer. And in the answer you have to mention 2 points. Red light has longer wavelength, so number of bright fringes less. So number of bright fringes decrease. Question 7 says a particle Q and a particle capital R are each composed of one quark and one anti-quark. For part A, state the name of the class of particles that includes Q and R, and that class is mesons, because mesons, they consist of one quark and one anti-quark. So simply we can say mesons. So this is in a better way you can write down. So we can simply say mesons. For the second part, for part B, it is given to us Q has a charge of -1e, where E is the elementary charge, R has a charge of 0. Complete table 7.1 to show a possible second quark in each of Q and R. So first of all, we need to understand the total charge is given to us. Then we have one quark. This is quark. So we can say charge on Q. So the charge on Q. Charge on Q is given to us. That is equal to -1e. And it consists of one strange quark. And this one should be one anti-quark. This has to be anti-quark. Then the charge on strange quark is -1/3e. So it means that the charge on this particle should be -2/3e. -2/3e. The charge on this one. And -2/3e charge is possible if this quark, if this anti-quark is anti-up quark, we can say anti-up quark. So it can be anti-up quark, anti-up quark, or it can be anti-up quark. In symbols we can write on, we can say this has to be anti-up quark, or it can be anti-top quark, or it can be anti-charm quark. So any one of them you can write on. So you can say this is anti-up quark. You can say, for example, you can say this is anti-up quark. You can also use the symbols. I mean, you can simply use this symbol, or you can say this is anti-top quark, or you can say anti-top quark, or you can say anti-charm quark. So any of them write down, your answer is correct. Now for the second particle, the charge on this one is equal to 0, and one particle is anti-up quark. So we can say for R, the charge is equal to 0. So here we have one anti-up quark. Anti-up quark. So as the charge on anti-up quark is -2/3, so here this is -2/3e. So we can say plus the charge on the second particle should be 2/3e. So this particle can be top quark. So we can say it can be top quark. This particle can be charm quark, and so on. So simply we can say here it can be top quark, or you can say this can be charm quark. So this is how we can answer. I hope this question makes sense to you. If you have any questions, please leave your questions in comments. And if you're looking for extra resources, please join Patreon. On Patreon, you will see a lot of resources in a very organized order. And also, if you have any questions from any past paper, you can ask me in the comments, and I will try to answer as soon as possible. And if these videos are helping you, please like and subscribe, because your encouragement is very important. See you in next video.